Hi, I'm Ms. Hearn. Let's get started. In this video, we're going to find f prime at a particular value a using the limit of the difference quotient, and then we're going to determine an equation of the line tangent to the graph of the function f using that derivative value. So here we go. First thing we're going to do is write down the formula for the limit of the difference quotient. And by the way, I have another version of this worked out where we use the quotient rule. But if you're asked to use the limit of the difference quotient, then this is how you should do it. It might also say use the definition of the derivative. So the definition is that f prime of x, the derivative, is the limit as h goes to 0 of f of x plus h minus f of x over h. Now, if you only want the derivative, if you want the formula for the derivative, you have to leave the x in there. But if you only want one particular value of the derivative, in other words, the derivative evaluated at a particular x value, you can replace that x with whatever the a is and do it all in one step. And that's how I'm going to do it in this video. So don't be confused if you see two different versions of the limit of the difference quotient. One with an x, that's saying you're going to get the general formula for the derivative, and if there's an a, they're saying a particular value a, like in this case 4. So in this case, we have f of x is 4 over 2x plus 1, and we're interested in the x value 4. So we're going to fill in to this formula. F prime at 4 is going to be the limit as h goes to 0 of f of 4 plus h minus f of 4 over h. And by the way, this very mysterious looking limit is really just a formula for slope. This is a y2 value, this is a y1 value, and the x's are 4 plus h and 4, so if you subtract x2 and x1, you actually get h. So that's your x2 minus x1. This is really just a formula for slope in function notation, and then when we evaluate the limit as h goes to 0, we get the slope of the tangent line. So let's go ahead and do that. To plug 4 plus h into our function f, we need to remember that the x you see in the function f is really just a placeholder. I like to think of it as a little box that we're going to fill. And so when we plug into that box, we get the limit as h goes to 0 of, I'm not going to write f anymore because I'm going to plug in here. We're going to have 4 over 2 times 4 plus h plus 1. You see how I've replaced that, I've filled in that box with the 4 plus h. And then I need to subtract what happens when I fill in that box with a 4. So f of 4, we're going to have minus 4 over 2 times 4 plus 1. So again, the little box was just filled in with a 4 this time. All right, and then in the denominator of this big fraction, we just have an h. So I'm going to simplify a little bit. So we're going to have limit as h goes to 0 of 4 over, distributing the 2, 8 plus 2h plus 1, minus 4 over, and here we have 8 plus 1, which is 9. Let's go ahead and change that 8 plus 1 to a 9 instead of making a whole extra step for that. So 8 plus 1 is really 9 plus 2h. There we go, all over h. All right, now, we learned in the previous chapter that we would really like to evaluate limits by just plugging in the value if that's possible, but you can only do that in the domain of the expression. In other words, if this value 0 is going to make this undefined, which it is because we have a denominator of h, then we can't just plug in. But we can solve that problem very easily by simplifying this complex fraction. Okay, so we're going to simplify this by multiplying the numerator and denominator of this large fraction by the common denominator of the two small fractions to get those denominators to cancel out. So 9 and 9 plus h are the factors that I'd like to cancel out. So I'm going to multiply by that on the top and on the bottom. And so this is going to give me the limit as h goes to 0 of, when you distribute this, it's going to go into each numerator. And the beauty of that is that we get to cancel a couple things out, right? So 9 plus h cancels with 9 plus h. It divides out to leave a factor of 1. 9 goes into 9 one time. And so we no longer have these little fractions in there. So what we have is the limit as h goes to 0 of 36 minus 4 times 9 plus h over 9h times 9 plus h. And we're going to simplify a bit. Distributing that negative 4, we have the limit as h goes to 0 of 36 minus 4h over 9h times 9 plus h. The 36's cancel. And as a matter of fact, now we have a factor of h in the numerator and 1 in the denominator. Those divide out and leave a 1. So we actually have the limit as h goes to 0 of negative 4 over 9 times 9 plus h. And now you notice we no longer have that factor of h in the denominator. That means we can actually try plugging in 0 again. And that will be negative 4 over 9 times 9 plus 0, or negative 4 over 81. So that is the value of the derivative at that particular x value 4. Or another way of saying that is we just found that the slope of the tangent line to f of x equals 4 over 2x plus 1 is negative 4 over 81 at the x value of 4. So there was a part 2 to this problem, which said, or part B, determine an equation of the line tangent to the graph of a at graph of f rather at a comma f of a for the given value of a. So a was 4. F of a is f of a is f of 4, which is 4 over 2 times 4 plus 1, which is 4/9. So we want to know the equation of the tangent line at the point 4 comma 4/9. Well, we all we need to find the equation of any line is the slope and a point. And we have that because we just found the slope is negative 4 over 81, and we have the point 4 comma 4/9. So we can, my favorite way to find the equation of a line when I have a point and a slope is to use y equals mx plus b. You could also use the point slope form of a line. But doing it this way, you're going to have 4/9 equals negative 4 over 81 times x, which is 4 plus b. So the only variable you're missing is the b, so we can solve for that. So we have 4/9 equals negative 16 over 81 plus b, adding 16 over 81, 4/9 plus 16 over 81 equals b. This 4/9 is the same as 36 over 81, which we're adding to 16 over 81. So b is actually equal to 52 over 81. And let's see, does that reduce? No, I don't think so. So that's your b. So to write the equation of the line, we're going to say y is equal to the slope, negative 4 over 81, times x, plus 52 over 81. So there's the equation of the tangent line. Hope you found this video helpful. If you did, please remember to give it a thumbs up. When you like the video, it helps other students to find